what I patched here, we will show it, I think, at the end. Again, I will explain what I did. But we will move on to the next example now, which Devan will do with you. And there we will see the concept of delegates, and once we explain that in the next example, we can go back here to this example and explain what I did right here.
Okay, the third example, we start exactly the same way as before. Save the patch. And we call the third example agency. And now we start the same way as the other example. We make a renderer, x9, to display our agents. Then middle click the layer input. We also use a point 2D for display purposes. And this time we do not generate anything in VUV. We just need the mouse input for interaction in VL. And in order to get the mouse, you create in VV the mouse devices window in that case. Mouse devices window. And that's basically it on the V4 part. And now, again, press V space, start typing template. And this time we do not use the stateless. We use the normal one, because this time we want to store states. So we want to store agents, we want to modify them, so we need to hold data over time. The stateless examples we did before, they are only functions. They do not remember anything. They are just input data, transform something, and output something. That's what this stateless means. So no storage over time. But this time we take the template value, which can store data over time. And again, control click, and then call it agency. Again, 2D, and clone. And then if you right-click the agency, it looks a little bit different. Basically, you see the same basic setup, but there's not this box around it. So this means you are in a stateful context. You can store data in here in pads. And we are going to use this very soon. But before we start here the agency, we will first create a very simple agent. So we will make our own data type that we then will manage in the agency. So there are several ways to create a new data type. One is you can go into the document patch by either clicking the document menu and click document patch, or you press this shortcut Alt plus P, and this will take you into a patch that is a higher level, so one level up. So here's the agency. You can open, if you right click the agency, you can open it, and then you're back in the agency patch. And in the document patch, you see here's the definition of the agency. And you can either here create a new type. For example, type here new patch. So this. But I'm not going to do it like this, but I stay in here, and here I press Control, Shift, and P. So Control, Shift, and P. This creates this node here, just a new node without any function. It's similar to cloning the template. So, and now if you go back into the document patch, you see this definition was created here. So again, this document patch shows you all the content of this file, all the definitions you created in this file. So in the agency, Control Shift P, you get this one. Then you can either middle click or right click open. And this leads you into the new data type you just created. And here we can rename it by either double clicking here on top or double clicking on the tab. It's both the same action. And we call it agent. And this is also a stateful context. Here we can store stuff over time. So we can store between frames, we can remember stuff and call it up in the next frame. And the agent will have a few properties. The first one will be the position. And the simplest way to create properties is double click, then type pad, and then give it a name like position. And now this value here, this pad here, represents kind of a storage place that you have in this type. If you click on this P here, you see that under properties you now have a new entry position. Here you see some kind of explorer view on your data type. Let's make another one called velocity. So double click, pad, call it velocity. And then if you click here, you see you have another property called velocity. And a very simple movement functionality is like just adding the velocity to the position and storing it back into the position.
Okay, you say you store the data and
Yeah.
of what type?
You see, this is like an empty circle. It's not clear yet. So it's not.
Could you assign at this point a type? Yes.
Yeah, we know the position will be a vector too. So we can already like either here right click the position and type, choose configure, or middle click the position to say, okay, we already know it will be a vector 2D, and then type vec, and then there should be some choices, and choose vector 2.
So
Not a spread, no, this will just, an agent just has one position, which is a two-dimensional vector. And now we can leave the velocity because, so the velocity is not yet clear what kind of type the velocity will be. But as soon as we add velocity, so connect the position to the plus, so greater plus connected. And then as soon as we connect the velocity to the input, it's also clear that the velocity also has to be a vector 2 because the position is. And the output of this is again, of course, 2D vector. And you can duplicate, press Ctrl D, the position, and we store it back. So this will be our main loop function.
You have to duplicate it, or you can just set up a new pad and call it out position.
There are several ways. If you have properties in your patch, you can also open the node browser and type position, and you automatically get it. Yeah. Or you create a pad, call it position. You can check it here. As soon as you type something that does not yet exist, it thinks it has to create a new one. But as soon as the pad has the same same name, it's a, but of course, simplest one is Ctrl D. All right.
So where's the position coming from?
Yeah, that's now the point. We want to create this agent somewhere on screen, so we have to give it an initial position. And again, if you click here the Explorer, you see, okay, here properties, then you see operations. So this agent already has 2 default operations that we created for you. You can create as many as you want, and we will do that later for hit testing it with the mouse. But for now, we just have the default, and that's create and update. And so we know whenever we press the middle mouse button, we want to create an agent and give it the mouse position as the initial position. And then we will also give it some kind of velocity for its movement. Right? And in order to do that, we of course need input pins. We can do them like very simple by starting a link here on top of the pad and then double clicking, and same for velocity. And now you see they are gray, and you see the same color here in the update. Ignore this. We can disable process. We are not going to use it.
I just got a question. Why don't we go straight from those squares into the plus and...
Because those are input pins. So this is data which comes from the outside.
Yeah.
And if you just connect it here, then you would just create a function of like adding 2 vectors together.
Okay.
But it's not what we want. We want to insert initial position, then we store it in the current position.
They're there for storing, like the properties store things.
Yes, they're like data fields, or
Sorry,
like
I didn't get that.
yeah. That's an what?
Pads what we used to do to frame delay if you wanted to store something exactly.
Yeah, it's the same thing. Just it has a name, and you can access it, and you can create it multiple times. So those 2 position pads, they refer to this single place in memory, you can say. And you can write stuff in there and read it. Another important thing is that we have those 2 operations here. And each of those operations defines a node that you can create in another patch. And the create, like the name says, creates an agent, and the update then updates the position. And in order to put those 2 input pins on the create position operation, that will then appear on the create node, we have to right-click them and say assign to create. And as soon as you do that, you see they get white, and this white corresponds to the create operation. And the same for velocity, assign create. And now we have those 2 pins on create. So on create, you take some data, then you store it into position and velocity, And then whenever the update function is called, operation, you will add the velocity to the position and store the position back to the field, so that in the next frame you have the updated position, and again you add the velocity to it, and this creates the movement for the agent.
Is create triggered when you add a slice to that input?
I will show this now how this all works together. So we just have this basic setup, and then we go back to the agency. And I was a little bit too fast. So this is the default setting. And then if you look in the node browser and type agent, we will only see these nodes with the 2 dots inside. And this is like an all-in-one package. It just creates all the operations. But that's not what we want. We want to have the individual create operation separated from the update operation, because we want to decide when we want to create an agent and when do we want to update it. So in order to get the operations as individual nodes, we have to change the type of this data type. So there's patch, which is the default. It's not clear yet what you mean. And then there's record and class. And just select record for now. So record. And now, if we now go into the agency and type agent, we see there's now this category agent. And if you click on this category, you will see the create and the update operation as individual nodes. And you see, if you hover the create, you already see the input pins here, position and velocity, both of the type vector2. And we can create this node and see, okay, takes a position, takes a velocity, then it outputs a new agent. So whenever this create operation is called, it creates a new agent. And I can, just to show it, also create the output, the update here. So this agent can now be connected to the update, and the update will give us a new agent with the updated position. If we do not call it, it will always be the same agent with the same position and velocity. Okay, so now we will input the mouse from before and then make an if condition to check whether the middle mouse is down, and then we create an agent, then we add this new agent to a list, to a spread of agents that we then manage in this agency. So in order to get the mouse input, you can create a mouse state node, this one, and then start a link from the output, double click, mouse device, is fine the name. We don't need those pins. So you see now we have this mouse device input, and you can connect the mouse to here. So this is the mouse that we can also here create a cursor that we see the mouse. Cursor DX9. So that we now see the mouse here in the window. Okay, so this mouse state has several outputs that gives us the current state of the mouse, like its position in the render, whether left is pressed, middle mouse is pressed, or right is pressed. And we already know that the new position for a new agent should be the mouse position, and take this first position, normalized position, and connect this to the position of the create agent. So this position will now come in here to the agent on create, and we just store it into this property. So, and for the velocity, we generate a random value. You can create a random. The random is also generic, so you connect it here, and it already knows, okay, I need to generate a random 2D vector.
So it's automatically generating two random numbers?
Yeah. And it also puts it into a 2D vector. And then from 2, the value range is very small. Here we make constant values, so start a link with one click, and then middle click here to create the from, and middle click again, create 2. And here we set very low values. Click on one number and right drag a little bit down, like this. So this part here is what we want to call whenever we press the middle button. So this is the creation part of the agent. So we can select this and then say surround with an if, like this. And like that we put everything into an if condition. You can also achieve the same thing in a different way, like if you create an if region, like this, you can select those nodes, drag it, and while you drag it, you can hold the control key, and as soon as you enter the region, the if region, it will snap into the region. This works for all region kinds. Oh no, I dragged it outside. So let me do that again. Like this. So now it's inside, and then I release the mouse. So then, what do we want to do with this agent? We have to recreate it, and then we have to also remember this agent we just created. And in order to do that, we need also a property in the agent that holds all the newly created agents. So here we also create a pad, and we call this agents. And this will be just a spread of agents. And similar to collecting the lines we did in the connect all example, here we add spread, add this agent to a spread. And we have to input the agents here with an accumulator. So start a link on the agent pad, click on the bar on the if, and then connect it to the add. And as soon as you connected it, it knows, okay, agents is a spread of agents.
But it's an empty spread at the moment, yeah? Up the top, it's an empty spread.
Yeah. This will be initialized with the default value, and it's a spread, so it's already something in memory, but it has no entries. It will be just empty.
But will it always be empty, or will the top hold in the end data as well, or just the bottom one?
Yes. Right now it will always be empty. Then it goes in here, and if we I just make a condition, make true. Now this if will be executed, and then all the time we will add 1. You see here input 0. Here you see this thing, and output 1 agent. And then we have this new spread, and we output it. The output here of the if region is a new spread with 1 agent. And now we have to store this new agent back into the pad.
Okay, and then it calls up the top. It calls back to what it.
Exactly.
Okay.
And if the condition is false, then we have an empty spread going in here, and we don't enter this patch inside of the if, and the output will still be an empty spread, because it just will pass the input here to the output if the condition is false.
But as soon as the condition is false, it will be empty again, like the agent.
Right now it will be
Okay,
empty.
But later on, not. Later on, it will have data in it.
Yeah, and now, we have to store it back into the agent property. So here, potentially a new spread comes out whenever the condition is true. And then we store it back into agents. And now I'll create an IO box here to visualize it. As soon as I now enable the condition, it will add one agent per frame. So have a look at this IO box. If I enable this condition, then you will add agents at every frame. So this is a good point to clear the agents. We sometimes want to remove all the agents. In order to do that, we can use a clear. And there's a cool feature in VL that VV doesn't have. You can double-click a link. You double-click, and then create a clear node, clear spread, and it just inputs the node into the link. And when do we want to clear? Let's say when we press the right mouse button. So on right-click, we clear all the agents, right pressed, like this. So now, when the condition is true, it will add agents all the time. So we have 215 agents in here. Now if I right-click on the window here, those 215 agents will be cleared, and the output can be 0 agents. And now this condition, of course, should be dependent on the middle mouse, but only if the mouse goes down, only on a down edge. There's a node for that called tog edge. So middle pressed, when the middle pressed value goes from false to true, so the up edge, then we want to add a new agent to the spread. And if you now have a look at this IO box, and I middle click here, on every click we'll add an agent to this property. Okay, now the first thing we do is we will draw the agents in VVV. And in order to do that, we need to get the position, the current position of the agent, or of all the agents, of course, in VV. And so what we can do is we use a for each loop that goes for each agent, takes the position, puts it into a spread, and then we output the spread to VV. So make a for each loop, for each, and then start the link here, connect it to the splicer, so the upper bar here for each, then right click, cancel the link. So here we get all agents we have currently, and inside of the loop we get one agent. And then for each agent we call the update. We click update agent. This increments the position. So this calls here this update operation, which is gray. Everything that is gray here, this part will then be called. So on create we storing those values, and on update we read position and velocity, we add it together and store it back to position. So we get a new agent. This has an updated position. And then to get the position, so to get an output pin, position output pin, we can start a link here from position, double click, and it automatically creates an output pin position. And this is automatically created here, update. And then we output the position. Am I too fast? Should I wait a second?
Yeah, you're a little bit fast.
Okay. So in the agent, create an additional output pin position. And if it snaps to create, you again right-click it, assign it to update, because we want to get the position whenever we update the agent. Yeah. Here you can either middle click the agent or right click open agent.
Makes it a difference if you make your output from the position or from the plus?
Here? No, there's no difference. It's the same value. Yeah. There is a difference if you use this position, because here, this is in the beginning of update, this is the old position, but here is the new position, and here as well as the new position. There's no difference. It's the same value. Yeah. Can do it like this or this. Because, yeah, the system knows it cannot be this old value, because
And if you would connect it to the right position, it would just hold the first create update.
no, here it no, it tells you there is no data storage in between. If you call update, this is just like passing values on it. That doesn't store the values. You need some kind of pad to store the value between the call of create and to the call of update.
And usually if you connect it to a position, like you did before,
Yeah.
in the long run it's often better like this, because when you insert more nodes, you don't have to switch that connection. And, it's just
Yeah, that's very convenient. Because if I do later, we will take care that the agents will not run out of the screen, and then we need to like have a confinement of the position in here. And then we don't have to draw two links here. Just have.
You can also create a new pad.
Hmm?
You can also create a new pad for this. Just duplicate the whole thing. So you never need to touch it again. You know what I mean?
Yeah,
This
that's
is our pad kopieren.
like this, but this is something different. If I do it like this, because the VL system takes care
Yeah.
that if you read from a property, it will always be in the very beginning of the operation. Here it cannot do that because there is a link into it and out from it in the same operation in update. So here it knows, okay, of course you mean the updated value. If you do it like this, this will have here exactly the same value as this one. In the beginning of update, you read whatever is currently stored in position.
Are you creating a new pad consume memory, or is this just a pointer?
No, this is just all those three position pads, they all point to this single place. Yeah. They are like aliases or representation.
But the bottom position is different to the top position, isn't it?
What do you mean?
The bottom position got the velocity in it.
Yeah, exactly. That was what I meant. So this would be a little bit wrong. You will always be one frame late. So
That's
this
a
would
bit wrong.
a little bit. It just is one frame too late.
it's like a frame delay
Yeah, frame
in
delay.
a sense.
So
Is it
This
like
would-
we had it before?
Yeah.
The value would be from the previous frame, so to say.
Yeah.
Because the velocity is not added yet.
But in the frame before you edit it, so you get the value from the frame before. Okay, so this is the best way you can do it.
Is there a way to navigate via a keyboard back and forth between those nodes?
Not yet, I think. Of course, there are many, like clicking on it and then you would navigate to something, but no, that's not possible. Okay, so back in the agency, here we create one agent on middle click. Then we get all agents. We take the position, and now for each agent we output the position and make a spread from it, like this. Try it again. Oops. Start a link, click on the lower bar, splicer. Then you have a new link, then you can double click and call this positions. And as soon as you do that, the VV node gets a new position pin, here positions. So let's connect the position to the point, and now as soon as I middle click, I create agents. And I output the position. But they're not moving yet. Does somebody know why they are not moving?
And if it's just popping up and going away, it's
Then you are not storing them back into the agents fields, probably.
And if they don't pop at all?
Then you are not. Then maybe you always clear the spread. Could it be that you always clear the spread? Okay, we are already calling update, but the agents are not moving. So, has anybody an idea why they are not moving?
We don't have velocity yet,
We already input the velocity, random velocity.
So,
But if you look here, we just take the created agents and store this to agent. And here, this updated agent never gets stored anywhere. So we always just store the initial agents. We remember them, they stay. But the updated agent is never written back into here. So in order to do that, we also have to output here the new agents, like this, and store them into the pad. And then, of course, we have to remove the old connection. And as soon as I do that, they should start moving. So select this, remove, and you see, oh, they stop moving. Here to give it a name, so for each agent, and then here output new agents, or updated agents. And this is just the position here. Pause. And since it's a common problem that you want to confine stuff to the renderer, there's a node that does this for you. And we could of course here check in the agency whether the position of an agent is outside the renderer and then set a new position or so. But the agent can take care of that for himself. And we create a node. which is called confine. And this is a node which is optimized for exactly this case when you update a position with a velocity. Here you insert the current position, then the last velocity that you have added to this position. And then here you can insert the boundaries. And for the minimum we need -1, -1, and the maximum is 1 and 1. So those are the dimensions of the renderer. So here we start a new position that gets reflected on the borders of the renderer. But as you can see, the velocity also has to be reflected as soon as the agent hits the border. So we also have to flip the velocity. So we need to store back a new velocity once the agent gets reflected on the renderer border. And now it should look like this, and all the agents will stay inside.
And why do they get reflected when we put it down the bottom? I get the last part.
Which one?
That they, because the new velocity, like.
The thing is, if you approach a border like this,
Yeah.
the velocity vector is like this.
Yeah.
And then, if it stays like this, it will just be there. But the new velocity, when it gets reflected, has to be mirrored on the.
Yeah.
So,
Yeah.
and the confine node takes care of that.
Okay.
It takes the velocity and reflects the velocity depending on the border.
Okay, so it does it automatically.
Yeah.
Okay.
That's it.
Look inside if you want.
Yeah, here.
Okay.
No, cannot. This is one of the rare cases. But it's also patched, I think. Somewhere it's patched. This is already fixed, I think, in the current alpha. So next step is we want to click the agents. And for that, they're a little bit too fast. And we will... So the values in here, they're already right small, a little bit small, the velocity vector, but we will make them even smaller by scaling this random vector further down. And there's a node, you can select the link, double click, press multiply scale. This scales some vector with one float. So if you want to have half the size of or so, for example, you can create this node and then scalar, and I think, I don't know, 0.25 or so. Let's try it. I think that looks okay. 0.2. Relaxed. And then let's give the, so this is a multiply scale. Also let's give the agents a size. And since they are just circles, we will call it a radius. So make a pad, radius. And we will just make this constant, so double click, type IO box, and then choose float 32, just one constant value, connect this to the radius, and then maybe set it to 0.1. Yeah, this one I created it like this. Double click, type IO box, and then float 32. Okay. Then we also pass this on to VV to draw the agents in the radius we set here. So start a link, double click, radius. Then you see in the agency, the update operation got a new pin radius. We also pass this on as a splicer to VV radius. In fact, the point in VV doesn't take a radius, but it takes a size. You can here convert the radius to a size by making a join vector 2. Oh no, it's just vector 2. Vector 2 join. I think. And put the same value in both. And then this. But as it's the radius is just a half of the size. We also need to scale this vector by 2. So double click, create multiply scale, and make 2. So now this is not radius but size. So here we get a radius, create a 2D vector from the radius, scale it by 2 to convert the radius to the size. And this can directly be connected to the size input of the point, and then you can adjust it here in the agent.
Can you just go back to agency?
Agency, yeah. Your radius, you type vector, vector join, and then vector 2.
Yeah, but
This is multiply scale.
I just when I drag out, I get an option.
Yeah, you took the normal multiplication, not the multiply scale.
But it wouldn't work like this too if you took a tool also.
Yeah, you can also use the normal multiplication and multiply by it.
And if we want to control the radius in V4, how do we get it out again? Top. I think now we put a constant.
Mm-hmm.
To get, instead of the constant, get it from V4.
You could create an input pin here, and then you get a pin here. Then you can make here an input radius. Then you can input it on every update if you want. Or if you want to have a constant, you add it on create, and then you would add the radius just one time, and it will stay like that forever. If you make an input pin here, if you make it on the update will be it can change it. Exactly. instance. Okay, now we have two more things left to do. So we will now check whether the mouse hits one of the agents, and if we hit one agent with the mouse, if we click at it, we will change its color. That's the one thing, and then after that, if we click it together with the color, we will change the behavior of the movement. So later on we will create 4 different types of movements for these agents. And whenever we click on one, we change the color and its behavior. So, of course, the click, so the hit test, whether it is hit by the mouse, should not always be triggered on update. So we don't want check the mouse intersection on every update. We just want to check it whenever the mouse is pressed. And so we cannot do it in the update all the time. And for this, we just can create a new node that also works on agents, so a new operation on the agent that's called hit test. And we call this hit test every time we press the mouse button. And that's very easy to do, so let's go into the agent and open the Explorer here, and then on operations we add a new operation and we call that hit test. So as soon as we created this new operation, if we go in here, go into agent, we see here we have a new node, hit test. But first we will add some functionality to this hit test. And what we want to do, from the outside we input the mouse position, and then we check whether the mouse is inside the circle of the agent. And this check, this intersection check, there's a function for it already. It's called circle. Circle contains point. And this needs as input a circle and the point. The point we already know, this will be the mouse position. So start a link from the point input, double click, and then call this mouse position. And we know we don't want to have, you see now that this input is on update, but we want to have this input at the hit test. So every time we call the hit test operation here, we want to have this mouse position. So we have to assign this input to the hit test method operation here, hit test. So, and you see now it got this blue color, which is the same as this operation here. So you see this part here of the patch will only be executed when the hit test operation is called. So to create the circle, we take the current position and the radius. So here make circle, join. Then input radius and position. This creates a circle type, which is just a mathematical representation of a circle, which has a center and a radius. And we can connect this circle to the method here, to the hit method. And as soon as you do that, it knows, okay, here it doesn't know when it should execute this circle operation. But as soon as you connect it, this all gets blue.
So it makes sense to connect this circle input to the operation.
To which one?
To the
Hit test?
addition operation. Doesn't matter, right?
No.
I mean,
No, we just create a circle to use this intersection method. Here. So you see this, all this blue stuff here is not executed on update. It's only executed when we call hit test. And to do so, we can insert the hit test node in here. So double click the link, hit test. Oh, and it doesn't have an output yet, because we are not doing anything in the test. So let's first create the color output.
so, but then again, when you connect this to the operation, the add operation, then the whole operation will also get executed another time. When you
Here?
Yeah. Just use the output of the add operation to go into the cycle.
Yep. Ah, that's more correct, yes, of course. Yeah, yeah.
Yeah, but now there was.
Yeah, but then you do another operation again, right?
Yeah, yeah, exactly. Yeah.
So you would do the operation for the update, and then once again for
Hit test. And you don't want that. No, you don't want it.
Yeah. So this is the right one, right?
Yeah. All this gray part here should only be on update. Only when update is called, you want to increment the position.
But as soon as you connect parts of the whole graph to the part of the cycle, which is assigned to the hit test, then the whole part of the graph will be part of this hit test operation.
Yeah, it automatically finds out what belongs to it.
I can explain what's going on there. There's a system simply makes a flat field. Okay, so you have some kind of seeds going on. For example, the white position input pins, then the blue mouse position input pin, and for example the radius output pin. So these are all seeds for the system, and then it will do a flat fill from there, and it stops at the pads, like this position and velocity pad. It will stop there. So this is why everything gets blue in that moment, because he connects the plus with the circle. If he does that, you see the whole thing gets blue. So it moves the whole graph to the hit test operation. This is not what we want in that case. So what you would need to do in that case, you would need to insert a pad on that link, so it stops flat filling. Okay, does that make sense? So the flat fill is only there to kind of make the matching easier.
But then again, wouldn't it make sense to connect the cycle to the lower position pad, to this one?
Yeah, but if you do a hit test, you don't want to update anything. You don't want to change anything.
It won't matter in the end, because he calls the hit test after the update or before. It doesn't matter. You already get the updated position. Okay.
Yeah, you read whatever is in there. You could also, here I just reused the position. I could also make the same like this and do this here and here.
Yeah.
So you see that it's a completely separate part of the agent. It's exactly the same. I just reused the position. Maybe it's even more clear to do like this. So this is just something the agent can do. It can take its position and its radius and intersect it with some position from the outside. And let's create some colors that we will cycle. So whenever we hit it, we want to increment the counter. So we counter, And then we want to get slice. Get slice spread. Some color values, and we just create 4 and const them together. So make a cons. And here the cons should have 4 inputs. This can be done by right-click, edit, increase pin count, or just select it, press Ctrl+. So we have 4 inputs. And then we have to create colors. This can be done by creating an iBox. Not IO box. And RGBA. And we make 4 of them. And we can leave the first one at right. Second one, hold Control, move the mouse up, right drag, move it up to some red. Second one, also hold Control, move the mouse up and then to the right. Make it some, maybe like bluish. And the last one, make it like yellow also. And to increase the saturation, you right drag up and down and hold Control. Left right is the hue. And we also have to tell the counter how much it should count up every time we hit. And so start the link, middle click, and then set the increment to 1. And then if the circle contains the mouse position, then we count up. And you see here the counter gets counted up on the blue operation.
Should we use a talk
No, because this is not called every frame. This is only called when we call hit test. That's a cool thing. So let's also output the color. Start a link. Double click color. And the color output should be on update. So if this is blue for some reason or white, assign it to update. And then back in the agency, we have a new pin here at the update, just the color. You can also pass this on to UV. So this hit test is not yet connected, it doesn't do anything right now. I've just routed the color output, which I created here. Also as a splicer out of the loop. So for each agent we get the color, pass it on to VVV, and then here we got a new pin, color, and that one goes to the point. So it's still white. And now I have to find a condition to call this hit test. So it should be in between here. So it takes an agent, does the hit test, and outputs a new agent that may have incremented the color. And if we now connect here the mouse position, normalized position to it, and then we hover over it, it will hit every frame and then cycles through the colors as soon as we hover it, but we don't want it. We only want to call hit test when the left button goes down. So the same, we need some kind of toggle edge here. Left button pressed. And then the hit test, we could put this into an if region, but this hit test also has a hidden apply, so show apply, configure, show apply, right click, which is an automatic if region around it. And this hit test should be called when the mouse button is pressed. Let's rearrange it a little bit. And now the hit test is only applied if the mouse left button goes down.
If you save VVVV, does BL save automatically as well, or do we have to save
No.
BL as well?
Now if you want to save the patch, you need to save the VV patch and the VL patch. They are two different files, and you can save each file individually.
Delegations still need the toggle edge, right? Because otherwise it's flipping through the colors if you click.
Yeah, the toggle edge is here. It's on the mouse button. If you would make a toggle edge in here, it could make sense, but it's more better to see if it's on the outside.
If you did a plug it in there, you couldn't click it again until your mouse was left to serve.
Yes, exactly. Yeah, it's true. Cool. So we have the basics set up. That we have created some interaction for each agent. Each agent takes care of whatever should happen when it is clicked for itself. And now we will use this logic to switch movement behaviors for each agent. But before we do that with the colors, we will just see how you can change the movement. And this is quite simple. If you have a velocity, the velocity vector defines the movement of the agent. And if you change this velocity vector, the movement will change. So if you, for example, rotate the velocity in every frame, it will make like a spiral movement. Or if you make a random vector, it will just like wobble around. So we do very, very basic behaviors. And so to change the velocity, we have to so in create we get the velocity, and on update we have the possibility to change the velocity to something else. So I could here, for example, read the velocity, rotate it a little bit, and then store it back into the velocity. But we are not doing it in here. We are doing it outside of the agent. And this is the interesting part. Because, for example, you are a developer and you want to like distribute this system to some other patchers, and then you want to give them this agency. So here you have the agency, but the movement of the agents should be like defined by the one who uses it. So, like for example, make a simple plus and add something to the velocity here. Yeah, so here if I add something to the velocity, they will get faster and faster. Oh, and I have to switch it here, of course, as well. Okay. So yeah. So this is a possibility too. So I will call some function that takes the velocity and outputs a new velocity. And it should be some node that has one input and outputs the same type again. And then what happens inside of this function should be defined by a third-party user that has the possibility to put something in there. And there is a concept called delegates that allows you to do that. And a delegate is basically only the functionality of a node. So here you can create a node. You know the signature of the node, one input, one output. But the function it has will be input like a value, but it's not a value, but it's the function what it executes. And this is called invoke. So you want to invoke a function, and you want to take. So you give the function one value, and you want to get one value in return. So delegate 1, and we create it as a node. So this is a node that can have any function in it that takes a value and returns a new value. And we input the velocity as the argument, and then pass the velocity on to our normal update logic of the particle. So here we have created this node, one input, one output, and the first input here now is of type function from vector 2 to another vector 2. And that's very interesting, because now you can create an input for that, like this. And then you get, on the outside, you get a new pin. It's called value. Let's call this behavior. So you don't have to follow right now. I'll just make an, show you how it looks. So here, now, behavior is a function from vector 2 to vector 2. And VL supports this kind of function types. They're called delegates in VL. If you start a connection and middle click, it creates you a template of this function. And now if I connect the input to the output, I will not change the velocity at all. So they have all velocity 0, so the 0 vector comes in. But if I create new agents, there will be just no change to the velocity. If you go back in here, velocity comes in here. Then on the outside, this function gets called, comes in here. Here I can change it. Right now I don't change it at all. I just pass it to the output, and then it comes out here again and goes back into the update logic. So this is kind of like routing the data outside, and somebody can modify it on the outside, and then you get it back. And this is a very, very powerful concept, because here on this, you see this connection, it looks a little bit different. This doesn't transport values like vectors or so, but it transports like actual, like a patch or some part of your program, part of your code. And now here we can, so if we do not pass on anything, they will just stop because the velocity, I can give it some good names. Velocity. As well velocity, or new velocity, even better. And here I can now patch some logic. And if I output a constant velocity, for example like this, they will just all move in the same way. So this is the basic principle, but we are not only inputting one functionality here, but we will here patch 4 different ones, put them together in a spread of functions, pass it into the agent, and inside here we will get slice one of the functions or delegates and use it as the behavior of the particle or the agent. Okay, so now I think I'll just do it again with you together. It looked like this. So go into your agent, create an invoke, delegate one-to-one node. This was a node in here. Then input the current velocity as argument, and then connect it like this. And then we know later we input for a spread of functions. So here we make a get slice spread. And we know, okay, we need one delegate, and the input should be a spread. You see now the type is spread of delegate vector 2 to vector 2. And this will be our input. Double click, behaviors. Like this. And then the get slice is the same as for the colors. The output of the counter like this. So together with the color, we will change the behavior of the agent. So what now happens? We have this behavior as input pin. And in the agency, some default will be created, which is like a function which just outputs the default vector. So they don't move right now. In order to get a spread of delegates, we create also a cons. And then connect the cons output to the behaviors pin. And now the cons knows, okay, all my inputs need to be delegates. So make 4 inputs. Then start a link, middle click, and it creates the. So let's make the first behavior just as it was before. Just pass on the original velocity as it was. In the second one, we will get a little bit more fancy. Here we take the velocity, convert it to a polar coordinates. Then we convert it back from polar. We take the same speed but we add a little bit to the angle, so the velocity will always rotate a little bit around. Like this. And the third one, we can just leave it like that, so it will be 0. It will just stand still. And for the fourth one, we can generate a random new velocity. So did we miss something?
You need to connect the velocity to the fine node.
Yep. Of course. So it is important to store the new velocity back. Yeah, before those two links were directly connected to the velocity. And now the modified velocity has to have the same connections. Okay, let's remove them, and now if we create the agents, the first, they will have an index of 0, and then it takes this delegate to execute. And then if you click it, they take the second one, and then they rotate, because the velocity will be rotated a little bit on each call. And then if I click again, it just stops. And now it's this one. And the last one is like random, just generates random values. And this, of course, works for every agent. Any questions or easy stuff? So same counter value gets plus color and the function behavior. Yeah, cool. I think this concludes the official part of the workshop today. And you are